Not
Okay,
sure.
gotcha.
Not sure here. So, all right. So let's say that there are 1,234 bugs, and I want this number in scientific notation. Okay, so this is a comma. It's not a decimal. The scientific notation has this part, which is called it's usually called the base times 10 to the power here.
Yeah.
So the decimal is here, 1, 2, 3, 4. And when you move it left, you count the number of places you move it left. So
Yeah.
then it's 1.234 times 10 to the power of 3 because I moved it left 3 places, or you count each of these.
Yeah.
Hopefully you saw that in class, or that's
I know.
all right. So the mass of the Earth, which I still find incredible that they actually can determine this value. It's quite large. So actually that's way too big. So let's not do that one. Let's just do a distance. So let's say your friend calls you and says, I'm 1,354,896 meters away from you. I'd like you to put this number into scientific notation. And like last week and previous weeks, I'll write down the correct answer and then you can compare to it and see if you got it.
Wait, so you move the like dot or
The decimal points. So you have to first figure out where it is. So in this problem, it's there. Here, the commas are just distractions. The decimal point is there.
Oh, okay. So okay, yeah, that makes sense. So you know where to move it with the first. I don't know where. Like,
We always move it. All the examples we're doing, you're moving it left.
okay, and how do we know how many times to move it?
Good question. So you move it until you get a number between 1 and 10.
Oh, okay. I kind of get it.
So I'll clarify that here. I jumped way ahead because I assumed that this was somewhat clear, but it's not. So let's go back to the previous example here. 1,234. Okay, so if I move the decimal left once, that becomes 123.4. Is that between 1 and 10?
No.
No. Let's move it another one. Is 12.34 between 1 and 10?
1 and 10?
Yes.
No.
No. And if I move it one more time, it is.
Yeah.
So 1.234 is. So that's how you know when you're done.
Oh, I see. Okay. I think I got it.
Okay. So let's say I give you 5, 9, 7, 2, 1, 2, 3. Okay.
Okay.
And I want this number written as a scientific notation number. So there's your decimal point, and you move it left until you get a number between 1 and 10.
Okay.
Okay, so basically you move it until you get down to that last digit.
So it would be like the decimal point would be right before the 5.
Yeah, like right there.
Oh, okay. Yeah.
And then you write everything after. So it's 5.9720000 times 10 to however many places you move this.
Okay. Okay.
And how many places did you move here? 1, 2, 3, 4, 5, 6.
Okay. So 10 to the power of 6.
Yes. Okay. So let's try a few here. Let's try a few examples. Let's say your favorite, well, I shouldn't say that. Let's say someone threw for 392 yards in football. That's an example. And then let's say that the new stimulus package in Congress is this much money. Let's see here, comma, 1, 2, 3, comma, 1, 2, 3, comma, 1, 2, 3. Okay, so let's put both of those into scientific notation. And I'll be right back. I'll check in with you in about 30 seconds.
Okay.
How's this going for you?
Good. I'm pretty sure I got the right answer.
So here's the answer to the first one.
Okay, yeah, so I
Is that what
got.
you wrote with the 2 up here?
Yeah.
Now for this next one, you actually don't have to write all of these zeros.
You can just skip right to the 3 and the 5.
Yeah, I mean, you need to count them, but you don't need to write them here. I know I did that in one of the earlier examples, but
Yeah. Okay, yeah, I got the right answer for both.
great. So now we have to go the other way. Let's say I'm going to give you examples where the numbers are less than 1. Okay, so let's say it's 0.0001234. So this time we're going to move the decimal right. Okay, so this time we're going to go this way.
Okay.
And I stop right there. The reason I stop right there is because this number, this thing I'm boxing in, this number is between 1 and 10.
Yeah.
So it's 1.234 times 10. But this time, because I moved the decimal to the right, and this is what you have to remember here, it's now a negative exponent.
Okay.
So when you move the decimal right, it becomes a negative exponent. When you move the decimal left, it becomes a positive exponent.
Okay.
And those are the only 2 things you have to remember out of all this.
All right.
All right, so let's try another one here. Let's try an example. Let's say it's 0.000000725. I want you to write this number in scientific notation.
All right, I'm done.
You got your final answer?
Yeah.
So it's 7.25 times 10 to the minus 7. Is that what you got?
Oh shoot, I did 10 to the minus 3 because I got confused on like I forgot to count the zeros.
You got to move your decimal right this time. See how this number is less?
Yeah, I
Then
thought
what?
because I don't know why, I just thought I would count the 2 and the 5.
So just like last week, we're going to do the same thing a bunch of times in a row.
Okay.
A bunch
Yeah,
of times in a row.
Okay.
And that should help. That should help. I mean, it's not a perfect plan, but it's better than doing one and thinking you got it. So let's try another example. Point 0.02015. Okay, so go ahead and try writing this in scientific notation, please.
Okay.
Okay, how are you doing? How are you doing on this? You all done?
I think I got it.
All right, so it's 2.015 times 10 to the minus 3.
Yep, that's what I got.
And you move it this 1, 2, 3. Okay. So if we're summarizing, I think this would be good to do, and then we'll do a couple of examples here. If the number is bigger than 1, okay, you move the decimal left and you get a positive exponent. That's what we did first. Those were the first examples. That was these up here. You move the decimal left, okay, and you get a positive exponent.
Mhm.
If the number is less than 1, you move the decimal right, and that gives you a negative exponent. So that summarizes what we just did in these examples. Okay, so let's do like a mixed review, and we're gonna just do we're gonna kind of just put a bunch of these together. So let's say I give you 1003. That's question number 1, and question number 2 is 0.1003.
Okay.
So see if you can do these on your own here. If you've been
Both
taking,
1 and 2.
yeah, or you can do just one, and then I can write down the correct answer if
Okay.
you'd like.
Okay, I got 1.
Okay, the first one is 1.003 times 10 to the third.
Yep, got it.
Okay,
Let me do the second. Alright, I got the second one.
the second one is also 1.003, but this time it's times 10 to the negative 1.
Yep, got that too.
Great. All right, so I'm going to assume you understand that.
Yeah, I do.
Those aren't the best examples, but they're good enough for what we're trying to do here. So we're going to do interesting. The order of this extra practice is odd. Is this the only practice that you were given today?
Yeah.
Okay. We're going to do 20 first, believe it or not.
Okay.
20 would generally come before the other ones, so I don't know why they did them in this order, but they did. Okay, so the first number is in scientific notation and the second number is not.
Yeah.
And you can't combine them unless they're in the same form.
Mhm.
And you generally go to you generally want to go to the not form. So we have to undo the scientific notation of this one.
Okay.
So since this is a positive number, this 5 here,
Yeah.
that means that we're going to move the decimal this way to undo what we were talking about before. So we undo
5
it 5
times.
times. So that's 1, 2, 3, 4, 5. You put zeros there, and your decimal goes at the end. So that's whatever that is. It's that number. I'm going to write this other number, 2, 4, 0, 0, 0, 0, 0. Now I have this nice grid, so that helps. I'm going to put this number underneath, like we're going back into a previous grade level. And this is how you add.
Yeah, that's how we're doing it. It's
And you only do it a little bit, and then you graduate out of this stuff. So this is your answer, but it's not in scientific notation. So you have to go back to scientific notation.
okay, I see.
So I want you to convert this number to scientific notation.
Okay, hold up. I'm just like writing it all down for
Sure, sure.
future.
I know I went through that pretty quickly. Take as much time as you need to get caught up to me on that.
Alright, I got it. I'm pretty sure.
How's that going?
Good. I got the answer.
So the answer is 3.13 times 10 to the 6th.
Oh, I didn't. Wait.
What did you write?
I
Did you
put
write this?
no, I did 31.3.
So 31.3 is not between 1 and 10. But
Okay.
3.13 is between 1 and 10. So you move the decimal until you get a number that's between 1 and 10. And generally you just move it right before the last digit.
Oh, okay. Yeah, because just doing the negative ones, it kind of confused me where I was doing it to like the last digit or like the last number. Well, yeah, the first number, I mean.
Okay, so do you have that down? This one?
Yeah, I get it now. Okay.
Okay, because we're gonna do another one. It's not exactly like it, but it's very similar. These are both in scientific notation, and you generally don't ever combine them when they're in scientific notation when you're adding, because that's what we're doing here. So we're gonna write these out in standard form. So
Okay.
8.64 times 10 to the sixth, you're gonna move this decimal 6 times. 1, 2, 3, 4, 5, 6. So that becomes 8640000. And then you can, if you want, you can get into the habit of putting commas in there every 3 digits. That's kind of a standard convention thing.
Yeah.
So 1.334. Now we're moving it 10 times because that 10 up there. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then you backfill all these zeros in here. Actually, I'll just do it in the next line because. Okay. And then the next thing is you move this number on the left. You want to move it underneath that number there on the right.
Okay.
And now you can add it up.
You add them together.
Yeah. And if you haven't added in a while, this way you always add from the right.
Yeah, I remember that.
Okay, so here's the decimal point here at the end. So give you another chance here. This is great practice for you. We're moving that decimal point left, and you're probably getting caught up here, but you're going to move the decimal left until you get a number between 1 and 10, and you generally move it all the way to the last position.
Is it? Okay. So is that like a hint to not move it to the last position?
What's that?
So I shouldn't move it to the last position on
Well,
this.
you're moving it, you're going to move it right there.
Oh, okay, yeah, that's what I was gonna
And
say.
that's kind of, I don't know how to say that. It's a
It
little,
sounded like you were like giving me a hint, like not to move it there this time.
sorry. Yeah, no,
No,
trying to be.
it's okay. Yeah, that's where I was gonna put it. That's where my thought process was going.
Let me know when you get this exponent here.
Oh, okay. Uh, 10 to the 11th power? Oh, 10.
I get 10, yeah. So I made these lines to kind of group them in threes. That's 3, that's 3, that's 3. So that's 3, 6, 9 plus one more. That's
Yeah.
10.
Okay.
Unfortunately, this is very detail, oriented.
Yeah, it is.
It really,
You can't make a mistake with these zeros and stuff.
no. The only thing that really makes sense to talk about is like money.
Well, yeah, money wise.
Like let's say you had this amount of money and someone was giving you this amount on the left, you be very sure to count these twice to make sure that you had the right amount.
Yeah.
Or if somebody owed you that amount of money, you would make really sure that that actually was correct.
Yeah.
So 22 is kind of like 20 in the sense that one number is in scientific notation and another is not.
Yeah.
So you always go to the not or the regular form or standard form or whatever. So 1.21 times 10 to the fifth. So I'm going to move that 1, 2, 3, 4, 5. So that becomes 1, 2, 1, and then I put 3 zeros there.
Yeah.
You're subtracting 9,500. So if you haven't done this in a while,
Wait,
yeah, this could be we can review this, or you can grab a calculator. It doesn't matter.
I think I got it. Right answer.
Okay, so that's the right answer. But what is it in scientific notation? This is the detail step. You got to be really attentive here to exactly how many times you're moving the decimal point.
Yeah. So,
It's 10 to what power? Do you have an answer for me, Remy? I can't hear you if you're talking. Maybe you're muted. Let me check here. He is gone. Hey, Remy.
Dude, I'm so sorry. My computer just shut off. I did
Uh,
not realize it was low.
Hey, no problem. Are you still seeing my screen?
Yeah, I am.
This is
I,
where we left off, and I was just asking you if you got the exponent here. Let me know if you got that.
oh no, I did not get that. I
Okay,
did
so that's
right.
where we left off. So just basically asking to count the number of times you moved it here.
Yeah, I remember that. Yeah, I put it.
Give me the number
Uh,
here. That's what I'm trying to.
oh, okay.
I want you to tell me that.
10 to the power 6.
So I'm counting here, just counting, right? 1, 2, 3, 4, 5.
Oh my, I keep counting a dot at the first part. That's why.
Oh, okay. Good, good. So when you're graphing ordered pairs, I assume you've done this at some point.
Yeah.
You don't count the origin, right? You start there. It's one up, two up,
Mhm.
right? One
I've been
right.
counting the dot usually this the whole time.
I see. So now it makes sense. So well, it's not a good idea to count the dot, but if you don't want to change, you just subtract one from your answer. But I would
Yeah.
just encourage you not to count the dot.
Okay, I won't.
All right. I want to do one more of these, but I'll make it shorter. But I really want you to do this one on your own, so that I can just believe that everything's fine. So let's go 1.1 times 10 to the fourth plus 2.3 times 10 to the third.
Okay.
So I want you to try this one on your own. They're not too big, so you can handle this on your own. Um,
Okay, I think I got my final answer.
okay, so let me write out each of these. Okay, so when I add them up here, you get 13300. So your final answer should be 1.33 times 10 to the fourth.
Yeah, I got it.
Great. Okay, so we've got enough time here to move to your other examples. There's really two different types of problems. You'll see one is multiplication and one is division. We'll do yeah. So they already give you 17 and 18. We're going to do 17 together again because it probably isn't clear. It's never clear when you see all the steps
Yeah.
together. You need them explained step by step. Okay. 3.7 times 10 to the minus 2. Notice this is not a plus, right? These are multiplying together.
Yeah.
Okay. Now, if I ask you to multiply 2 times 3 times 4 times 5, do you know that you can multiply the first and the third and then the second and the fourth?
Yeah, I do know.
Okay, so it's the same idea here. You end up multiplying these two numbers together, 3.7 times 1.2. And do you have a calculator handy?
Yeah.
Okay. Go ahead and tell me the result of multiplying those together.
Wait, it's 3.7. I'm doing it on my computer.
Okay,
Well, yeah, it's 4.44.
good. Okay. Now these here, this is the harder part. So you have 10 to the minus 2 and 10 to the 3. So we learned about some rules last time. We talked about if you have x to the n, times x to the m. And what this means is that the bases are the same. Base is same.
Okay.
When the bases are the same, you add the exponents. You add the exponents.
Wait, let me ask a question. But can you do like how 10 to the third power is like 30? Can you just like add those together, or I mean multiply them?
Okay, 10
And
to
then
the third power is not 30. 10 to the third power is 10 times 10 times 10.
Oh my gosh, yeah, dude, I'm blanking out right now.
That's okay.
Can you do that and then add them together as well as with
No, because you're not adding here, you're multiplying.
Can you multiply? Can you multiply? Can you multiply them together?
So, but okay, so what you're asking here, okay, and what you're asking you can actually do, but you're making more work for yourself. 10 to the negative 2 is 0.01.
Oh,
So do you want to multiply those together?
no.
No. Okay, so it's really much simpler. Okay, you take this negative 2 and this 3 and you add them together. What's negative 2 and 3 added together?
Negative 2 and 3.
Yes.
Oh my gosh. 1.
Yep.
Okay.
Okay, we're gonna do another example here. 2 times 10 to the 5th, 3 times 10 to the 8th.
All right, I'm gonna solve that.
Yes, and again, you're multiplying the first and the third, then the second and the fourth.
Okay. Wait, can you scroll up a little bit really quick? Okay, thanks. Okay, I'm still kind of confused on like how to add the last numbers on each side.
What is 2 times 3?
5. I mean, oh my gosh, 6.
6, right?
Mm-hmm.
Okay, and then because the bases are the same, because the 10s are the same, you add 5 and 8. So it's 10, 5 plus 8.
Okay. And then you just add those together and then do 10.
That's your final answer.
Oh, okay. I was overthinking it. Never mind then.
Yes, it's 2 steps. You multiply the first, then you add the exponents.
Okay. Yeah.
Okay.
Okay. I was overthinking that way too
Let's
much.
try another one here. Okay, so again, you multiply the first and the third.
Yeah.
Let me know when you get your final answer here.
Okay. Gotcha. Is it 6 with the dot and then the 10 and the
What number goes up here?
The -4.
Perfect.
Okay. Cool.
Okay, so here's a small variation on what we just did. Okay, let's say I want to multiply the numbers 10,000. Actually, let me change it. I want to multiply the numbers 20,000 times 45. Okay, now I know you can just grab a calculator, right? But that's not the point here. We're going to first convert each of these to scientific notation.
Okay.
So the first one is 2 times 10 to what power? 1, 2,
Four.
3, 4.
4.
The second one is 4.5 times 10 to what power?
2 or 1, just 1.
1.
Yeah.
So now I want you to multiply these together and give me the final answer.
Okay.
Then we'll move to some division problems.
All right, I got my answer.
So your answer is 9 times 10 to the power of 5.
Yeah, I got that.
Great. Excellent. Okay, so let's move to your next assigned problem here. There it is. Let's do, all right. 18. Okay, 18. So do you see this big fraction bar here?
Yeah.
So you're doing division.
Okay.
And you do this that I've boxed in, then you do the next part.
Okay.
So you said you have a calculator. I want you to divide 4.64 by 2.9.
Wait, what was it?
4 points. Do you see my screen?
Oh yeah, I did.
Okay, 4.64 divided by 2.9.
Oh, 1.6.
1.6. Okay. Now this time the bases are the same, but you're dividing. Do you see that?
Yeah, I see that.
So when you have the same bases and you're dividing, you subtract the exponents. You take -4 and subtract -6. So think of this fraction bar as a big subtraction symbol. So it's 10 to the -4 minus a -6 power. So you subtract them.
Okay.
And it's important to write it this way because you're going to distribute the negative.
Mm-hmm.
So it really ends up being -4 plus 6,
Mm-hmm. Okay.
which is positive
10.
2. 2, because this is negative, this is positive.
Yeah.
Okay, let's try another example here. 8.1 times 10 to the -5 divided by 4.05 times 10 to the -9. So just like in the previous example, you're going to divide these first.
Okay.
So if you have a calculator handy, go ahead and divide those.
Okay, so it's 2.
It is 2. Now, as I mentioned, when the bases are the same and you're dividing, you subtract the exponents. This is times 10 -5 minus, even though there's a minus there, you still have to subtract it, -9.
Mm-hmm. Okay.
So what does that become? What is the exponent up here?
Oh, wait, so it's -5 minus -9.
Yes.
Is -14.
This negative goes with this one and makes it positive. So it becomes
Oh,
-5 plus 9.
Oh, I see. Okay. I don't know. I've never seen that before for some reason.
It's the negative of a negative. Like it's like saying I'm not going to not clean my room. That means you are going to clean your room. Whenever you have two negatives,
So
they cancel each other out.
so 4.
Yes. So this is 2 times 10 to the 4th.
Okay.
All right. So we're going to do 19 just because we don't have a ton of time to be able to do a bunch of examples here. I wish we had just a little more time.
It's all like the same thing, so
This one's slightly different. I'm actually surprised they gave it to you this way. Go ahead and punch in your calculator 3.24 divided by 8.1.
3.24 divided by what?
8.1.
Okay, 0.4.
Yes. Now, here again, you're going to have to subtract the exponent. So it's -4 minus
7.
a -7.
You turn it into addition, right?
Yes. So this becomes 0.4 times 10, -4 plus 7.
That's 3.
Okay. Problem though, this is the first one we have like this. Is this number between 1 and 10?
No, it's not.
No. So let's keep this really simple. 0.4 times 10 to the 3. You're moving the decimal to the right. 1, 2, 3.
Yeah.
So it's really 400.
Okay.
So how do you write 400 as a number in scientific notation? Well, and you have to go backwards, but you don't go back 3 because that gets you to 0.4. You only go back 1, 2.
Ew.
So it's 4 times 10 to what power? You don't count the decimal, so you count 1,
To the power of 1, 2.
2. Perfect. Okay, so that's your final answer for that.
Okay. Yeah, they're all like the same thing.
Yeah, I would definitely encourage you to try these again. I know not right now, maybe sometime today before bed or in class tomorrow, but try to hear the words, not necessarily the actions. Hopefully that'll
Yeah.
resonate with you.
Oh, this is cleared up 100%. I was like really not sure about this at all.
Great. Well, thanks for scheduling. I'll send you the notes and the screen recording out shortly, and I'll see you next time.
I got you. Thank you.
Have a good night. Bye now.